Hi guys, I hope you're having an awesome day. Today we're going to compare these four molecules and look at their rates of evaporation. So we have water, we have hexane, we have acetone, and we have methanol. And I have four beakers right here that contain about 10 milliliters of each of these substances. So what I'd like you to do is, looking at their structures, try to predict which one would evaporate the fastest and which one would evaporate the slowest. So we're going to say 1 would be the fastest and 4 would be the slowest, and I'd like you to rank them from 1 to 4. So pause the video, try to figure it out, and then we're going to look and see what happens. So hopefully you've tried to figure it out. I'm going to go ahead and pour the beakers over these paper towels as fast as I can. So do water and hexane first, and then the other two. And we're going to observe and see which of them will evaporate first. So I'm going to give them a little bit of a helping hand here, and I'll do each of them equally. And let's see, you can kind of tell one of them is already going. Can you tell which one? Looks like hexane is already evaporating here. So how would you tell? Well, you probably want to figure out what type of intermolecular forces they have first. So let's assign each of them their intermolecular forces. So water would have hydrogen bonding. Oh, look, the hexane is almost gone here. So it looks like hexane is number 1. I'm going to say 1. And let's look back. It looks like, which one can you tell is going second? It looks like acetone is going second. And I'm going to help out my water and my methanol a little bit, get them to go a little bit faster. So you want to assign what type of intermolecular forces they have. So water has hydrogen bonding. How about hexane? What do you think? Well, it has London dispersion. Acetone, that would have dipole. It's polar, but it doesn't have a hydrogen bond, so dipole. And then finally, methanol, it has hydrogen bonding as well. So which one has the weakest intermolecular forces? Well, that's going to be the hexane, right? Because it has London dispersion, so that's the weakest type of intermolecular force. And so it would make sense that it's going to evaporate the fastest, because if it has the weakest intermolecular forces, particles are not very attracted to each other, and so they can very easily separate and become a gas. Followed by dipole interaction, so that would be the acetone, so that goes number 2. And then methanol and water have both hydrogen bonding, but if you remember from our previous conversation about hydrogen bonding, we said that water has stronger intermolecular forces total than methanol, because water has more sites for hydrogen bonding. Remember, everywhere in water you have a partial positive or negative to attract other water particles, whereas in methanol you have a partial positive and negative where the oxygen and the hydrogen are there, but not where your carbons and other hydrogens are. And so you would predict that this would be number 3, and the water would be number 4. Let's look back at them and see. It definitely looks like the methanol is evaporating faster than the water. So you always assign the types of intermolecular forces, rank them, and from there you can come up with all kinds of properties such as evaporation rate. Have a great day.